for a while now, and yeah, it's fairly well behaving, but there is a trend. I think there's a I'm running that over the wide network, so there is I think there's increased in the traffic at that point, and I think that's all there is to it. So it's been running steadily, and I'm looking at the different two different transaction types. I have combined some users that would just be read-only users, and some users that would generate a new instance in the system, and they would go through as I continue to run the test. I have a number of information there, so the black lines there and the black line there is an overall time for that transaction to complete. I have my user population there, but I also have a detailed breakdown of individual steps for each of those transactions, so that I can break it down to where the time has been spent, so that if something happens, and well, that might be one example. There was a slight peak there. Nothing, I don't think anything to worry about, but if something like that happened, I can relate that to sub part of the whole transaction and then look at why that would happen. It might be a search, it might be database intensive application that is the transaction that is happening at that point, so that will give me clues. I can also collect information about the utilization of resources on from various layers, so that I can relate the user experience to the utilization of the underlying resources. The whole process, as I said, it's the running of the test. It needs to be flexible. It's a very powerful way of having dynamic control over what is happening, so that I can increase the load and see what would happen if I would to add some more users on the system at the same time as I'm talking now, and see how the performance would be affected through that. But the other side of that is you need to be able to build a test fairly quickly. That needs to be, the process of creating tests needs to be simple enough. And we represent transactions as a sequence. Basically, it's a type. There is no programming as such. We represent calls as what they are. So we have some ITSM. We represent them as break them down as in terms of what the data is sent. So we relate those calls to what they mean, rather than keeping them separate from there. That means that we can extract the data much easier. So, for example, one of the views of the transaction is just looking at the data that is coming back and forth from the system, but represented in terms of, well, similar to what Remedy API would be, so that you can actually see and understand transaction, rather than worry about the protocol that's just carrying the data across. So that process, we've done, I said, a lot of work. So the process is a capture. Then we're doing some post-processing that would introduce and relate individual transactions, break them down in terms of what they mean. So if we treat the individual calls as a back channel calls, rather than just pure web calls, where the data is presented in a way that it can be easily manipulated and processed. We also automatically handle data response validation from the individual call. So if the call is returning remedy level error, we will pick that up and return that as an error. So even if the web call itself succeeded, so you don't need to add manual handling. Overall, speeding up the whole process, so that instead of spending days building a single test, you can do that in an hour or so, so that you can easily repeat things when needed. Once that is completed, you are left with a can see things are slowing down because I said it's wide area connection that I'm running that across, and I think I'm running out of bandwidth there. But once we've done that, we can either start creating very complex reports or even produce a very, very simple breakdown of what was happening, how many iterations we were running, what would the average timings, and then that broken down to individual activities on the system so that we can compare them easily as the things are progressing. So that's the whole process. If you are validating changes, if you keep your test quite simple, and that can mean creating a new incident is not a complex transaction in terms of what I mean by that, because you have users logging in. You would have you would load one of the consoles, incident management console, then you would generate a new incident. Maybe you would process that incident, close it. That's a single user interaction with the system that will exercise quite a lot of components within that, but it can be created very quickly. It would be quite easy to repeat that in a test, and you can compare results easily. So that's one example. So going back to that, as a conclusion, I said you need to keep it simple. At least initially, you need to be able to repeat those things often. So if you cannot do test in a day and you're just testing a smallest change from them, so if you cannot do that in a day, from the moment you build a test, create the results, and produce a report, something is being overcomplicated. Define clear objectives. Your test will produce the results that if you know what you're looking for, you can get a test that will answer that question. Have very specific questions. Optimize and revalidate. Try. It's sometimes there's a lot of time is spent discussing whether certain parameters will work or not. Easiest. Test before, test after. Test two sets of parameters, compare the results. It's sometimes very, very easy to see what will work. And as I said, often configuration or optimization will work on one system, may not work on a different system. Add complexity only after your previous cycle has been completed. Add more transactions as you need to expand. Understand your results. Keeping things simple means that you can relate the results to what they actually mean. Understand your system performance profile, because you would be repeating, if you repeat the cycle, you can break that. Let's say that you have 5 days for testing. It's much better if you break them down in 5 one-day tests, then put them all at the end, because you will see the trends, you will see the changes, you will know where they're coming from. So understand your performance profile. Next time you run a test, you will know what to expect, and if things are not the way they expect, you can pinpoint where things are going wrong. Meaningful results may mean that you may do some sensitivity analysis. You may start evaluating what the different searches may do to your system, or different data loads, different data structures may do that. If you certain form is returning too much data on a drop-down menus, may create problems on one side and the other. So you can start fine-tuning the system, but it's the simple transaction will give you quite a lot of information that you need before you can fine-tune the system. No point fine-tuning something that is not stable and it's not performing well. Monitor the changes. As you continue, you monitor the changes and you start to address them. Okay. So that was what I rushed to that. It's quite a lot to cover. So I think Ian mentioned we're planning to do a set of those, and I think what we will try to do over a period of time, we pick up one of the case study or focus on one of the things that I mentioned here and look at that in more detail. Because I guess this initial one was just to go through an overview of the process, and then we'll have more focused ones. I well, I'm sure I haven't covered all of it, but if you have any questions or area that you might be of interest to you, I think if you get back either to Ian or to me, we can easily arrange something as a follow-up and or just make sure that we cover that in a future webinar. Thank you.